In example number 2, same type of problem as the first example, just a pretty straightforward linear equation in one variable. We're going to begin by distributing the numbers outside the parentheses. So negative 7 times 2x is negative 14x. Negative 7 times negative 2 is positive 14. Then we're going to have positive 5 times positive x is positive 5x. Positive 5 times negative 1 is negative 5 equals negative 10x. I'm going to put together my like terms. The x's combine to be negative 9x. The non-x's combine to be positive 9 equals negative 10x. Now at this point I'm going to move terms to the same side of the equal sign, so I want all my x's on the same side. This time I'm going to move my x's over to the right hand side just because my only non-x is on the left. So it makes no sense to move it as there's nothing over here to move it to. So I'm just going to leave the number 9 here and move the 9x. So we're going to add 9x to both sides. The negative 9 and positive 9x cancel. So we end up with 9 equals negative x. So we will finish this by dividing by negative 1. I'm going to flip-flop sides of the equal sign to get to x equals negative 9. This next example is another one that involves fractions. We can just see another one at work. I begin by multiplying everything by the least common denominator, which would be 4. So the equation becomes 4 times x over 2 plus 4 times 4x minus 5 over 4 plus 4 times 2 equals, it's going to be 0 on this side. This 0 should be multiplied by the 4 also, but I'm just kind of running out of room on my paper here, so I'm just going to leave it 0. This would be the result anyway. Now we reduce the fractions. 2 goes into 4 twice. 4 just eliminates 4 completely. And of course there's no fraction here to reduce the 4, so that's just going to stay. The result is that I have in the first term 2x plus the second term, the 4 canceled, so there's nothing to distribute, so writing without parentheses, 4x minus 5 plus the 4 times 2 there makes 8 equals 0. I'm going to combine my like terms, giving me 6x plus 3 equals 0. I'm going to subtract my 3 across, giving me 6x equals negative 3. Divide by our 6, giving me x equals negative half. Next example, solving a linear inequality, just like the last one. I'm going to begin this one with the distributive property here on the right. So we have negative x minus 15 is less than 3x minus 18. Bring down that minus 5. My like terms here result negative x minus 15 is less than 3x minus 23. Now I'm going to move terms around. The 3x I'm going to subtract across. The 15 is already negative, so we're going to add it. Okay, the result of doing that, we have negative 4x less than negative 8. Divide both sides by negative 4. Because I divided by negative, the inequality will flip. Get x is greater than 2. You can draw a number line if you want. Really, I'm just interested in the interval notation. Greater than 2 would mean start at 2, shade towards infinity. We never equal infinity, so always round it on infinity. And since we're not equal to on this one, we're going to be rounded on the 2 also. The last problem in this section is another double inequality to solve. I begin this one by multiplying both sides by 3. I technically multiply the middle by 3, but that's what cancels that out. So I end up with 9 less than 2x plus 3 less than 15. I'm going to subtract 3 out of the middle and put it on both ends because I'm solving two problems at once. So I end up with 6 is less than 2x is less than 12. I'm going to divide by 2. It's going to give me on the left side 3 is less than x, which is less than 6. Okay, so if I were shading on a number line, I would be shading all the values x between 3 and 6 because I want everything that's smaller than 6 and bigger than 3. So that's going to shade everything between 3 and 6. It'd be open circles on both ends as we are not including the 3 and the 6, but knowing what the number line looks like leads me to my interval notation 3, 6 rounded on both numbers as we're not equal to on either number.